How to compare rational numbers? Let's start the discussion by comparing two integers. Now, if you are thinking why integers, then remember integers are also rational numbers. So first, let's discuss a very basic thing, then we move to the discussion on comparing the rational numbers of the form P over Q, right? So when we compare integers, let's take an example. Let's say you have to compare 3 and 5. You'll say that, hey, that's really very easy. Of course, 5 is greater than 3. So if you represent this on a number line, let's say this is a number line, and let's say this is the mark of 0, and 1 comes here, 2 comes here, 3 comes here, 4 comes here, and let's say 5 comes here. So 1, 2, 3, 4, and 5. Now, of course, if this number 5 comes here and this number 3 comes here. That's why we can see when we move towards the right on a number line, then the value goes on increasing, right? 5 over 3, 5 is greater than 3, therefore 5 comes here towards the right of 3. That is, the higher value will always be towards the right. Okay, now what if someone asks you that what if you have to compare 3 and minus 5? Now you know that whenever we compare a positive number and a negative number, then of course the positive number will always be greater, So in this case, 3 is always greater than minus 5. Even 0 is greater than minus 5. We know all these things. We have studied in our earlier class. So if I have to represent this on a number line here, if I mark this side, let's say this is minus 1, this is minus 2, this is minus 3, this is minus 4, and this is minus 5. Now, in this case, your minus 5 comes here, right? And your 3 is here. Your 3 is here. Of course, 3 is greater than minus 5 because we are comparing a positive number and a negative number. So again, the greater number is towards the right, right? This minus 5 is towards the left and this is towards the right. So greater value will always be towards the right on a number line. Okay. What if now you have to compare minus 3 and minus 5? Minus 3 and minus 5. Again, your minus 3 is here and minus 5 is here. We know that whenever we compare two negative integers, then always the number that is smaller with the negative sign will be greater. We know this, right? So in this case, minus 3 is greater than minus 5. Number that has negative sign, which is smaller in value. So 3 is smaller than 5, therefore this is greater. And again, if you watch it on a number line, 3 is towards the right of minus 5. 3 comes towards the right. Minus 3 comes towards the right to the minus 5. So again, minus 3 is greater than minus 5. Okay. Now let's move to fractions. So what we're wondering, hey, first we discuss integers, now fractions. Yes, because fractions are also rational numbers, and as I said, first we'll discuss very basic, and then we'll move to P over Q form. So fractions are of the form P over Q, right? P over Q, where P and Q both have to be positive number, and Q cannot be equal to 0. That's the condition of a fraction. So P and Q both have to be positive. Let's take an example. Let's say that you have to compare 5 over 4 and 3 over 8. Now, 5/4 and 3/8, if you remember, we have discussed this comparison of fractions when we were learning about fractions, right? So if you haven't watched those videos, I request you to go to the playlist of fractions, and you can find those comparisons there, right? The tutorial on comparison of fractions there, but still I'll again explain. Whenever you have to compare two fractions, what you have to do is first convert these two fractions in like fractions, make them like fractions. What's the term? Like fractions. And like fractions, our aim is to make the denominator of the fractions equal. So we have to make the denominators equal. That's our same value. We have to make denominators equal. In this case, this is 4 and this is 8. For making denominators equal, the best way is to find out the LCM, that is the least common multiple. In this case, you have 4 and 8. Now, if you try to find out the LCM of 4 and 8, this gives you 8. 8 is the LCM of 4 and 8. Now we have to convert these two fractions in their like fractions, right? That is, to convert these two fractions into like fractions, you have to make denominators equal. For making denominators equal, you have to first find out the LCM. Now, if you have find this LCM is 8, by what number we are doing for this one, 5/4? By what number we should multiply 4 with such that the denominator becomes 8? So clearly, if I multiply this 4 with 2, denominator will become 8, right? Since we have multiplied the denominator with 2, we also have to multiply the numerator also with 2, because we are making these two fractions as like fractions, and this will be an equivalent fraction of 5/4. Okay, what about this one? By what number I should multiply the denominator, that is 8, with such that it becomes 8? Of course, by 1. So 8 times 1 becomes 8. The thing is that your denominator should be equal to the LCM. Okay, so first find out the LCM and then do this process of making the denominator equal to the LCM. So 8 times 1 will come 8. So since we have multiplied this denominator with 1, so we also need to multiply this numerator also with 1. Okay, now what does this become? It becomes 10/8, and this becomes 3/8, right? 10/8 and 3/8. Now clearly, these two fractions are like fractions. These two fractions have now become like fractions. If these are like fractions now, then we know that when we have come to a point where we have like fractions, then we compare numerator. We compare numerators. In this case, we have numerators as 10 and we have numerators as 3. Now that's really very simple. 10 is of course greater than 3. So if 10 is greater than 3, we say that 10/8 is greater than 3/8. And why? We compare the numerators, and since in this case 10 is greater than 3, therefore this fraction is greater than 3/8. That means this 10/8 is actually what? Is actually an equivalent fraction of 5/4. Is an equivalent fraction of 5/4. And this 3/8 is an equivalent fraction of 3/8 because we have only multiplied with 1 only, right? It's same only. So that means that since 10/8 is greater than 3/8 and 10/8 is an equivalent fraction of 5/4, therefore 5/4 will be greater than 3/8, right? Now, if you have to represent this comparison on a number line, how you do this? So take a number line, this here and this here. In this case, I'm not focusing on the negative integers because we don't have any negative integer here. So I'll start my 0 from here. Okay, I'll start my 0 from here, and then we go on dividing this. Now, if let's say R1 comes here, then suppose 2 comes here. Okay, I just magnified these two distances, right? So that we can have a better explanation, better understanding. This is 0 to 1, then 1 to 2. Now, this denominator 8, we have both the denominators as 8. This denominator 8, what does that mean? It means that you have to divide each unit into 8 equal parts, the concept of fraction. I'm again repeating, please go to the playlist. Even you can go to the earlier videos of this same playlist, okay? So, of class 7th mathematics playlist, you can go to the earlier videos and watch those videos. That will be really helpful to you. This 8 means that divide this each unit into 8 equal parts. Let's do this. So, this is 1 part, 2 part, 3 part, 1, 2, 3, 4, 5, 6, 7 and 8. So though they are not really equal in size, but assume that since we have drawn with our rough hand, assume that these are equal parts. So 1 part, 2 part, 3 part, 4, 5, 6, 7 and 8 part. What is this fraction tells us? Okay. This becomes 4. This becomes 1 over 8. This becomes 2 over 8. This becomes 3 over 8. This becomes 4 over 8. This becomes 5 over 8. This becomes 6 over 8. And this becomes 7 over 8. And this 1 is actually 8 over 8. If you divide 8 with 8, what you get? 1 only. Right? And that makes sense. Now, again, we divide this into 8 equal parts. So, 1, 2, 3, 4, 5, 6, 7. Okay, 7 marks. It means 7 marks will divide this unit into 8 equal parts. So if 1 was 8 over 8, this becomes 9 over 8. This becomes 10 over 8. This becomes 11 over 8. And so on. Finally, we reach here and this 2 becomes 16 over 8. 12 over 8, 13 over 8, 14 over 8, 15 over 8, and this becomes 16 over 8. If you divide 16 by 8, you get what? 2. Okay. What we have to compare? We have to actually compare 3 over 8 and 10 over 8. Always remember that the most important thing while comparing two fractions or two rational numbers, because fractions are of course rational numbers, always convert them into like fractions and then compare them either by this method what we have done, or if you want to even try to represent them on a number line, always use these like fractions. Okay, so where does this 10 over 8 comes? 10 over 8 comes here. 10 over 8 comes here, right? And where does this 3 over 8 comes? 3 over 8 comes here. Of course, 10 over 8 is right to the 3 over 8. That means whenever we move on towards right on a number line, our value always increases. Okay. So here we first compared it like this and then we represent the same comparison on a number line. Okay. Let's move to another point. Here we compared what? Here we have compared 5 over 4 and 3 over 8. What if we have to compare minus 5 over 4 and minus 3 over 8? We have to compare this. Now see that we have two negative numerators, right? In this case it was 5 over 4 and 3 over 8, but now we have minus 5 over 4 and minus 3 over 8. We are going to do same thing. What? The same steps. You have to convert them into like fractions, and like fractions always have same denominators, so you'll have to take the help of LCM. So since these two numbers are same, but only difference is that they have now negative signs in the numerators. So all the steps will be same, only there will be a negative sign in the numerator. So this, as we have done here, this 5 over comes as what? 10 over 8. So if we follow all those steps and convert these two fractions in like fractions, this becomes minus 10 over 8, right? And this becomes minus 3 over 8. This remains the same because the LCM comes as LCM, as we have seen earlier, is actually 8 of 4 and 8. Now, minus 10 over 8, an equivalent fraction of minus 5 over 4 and minus 3 over 8. Again, compare numerators. The next step is compare numerators. We have two numerators. You have minus 10 and you have minus 3. Clearly, minus 10 is less than minus 3, because negative sign, when the negative sign is with a number that has smaller value, then that number is always greater than the number having a negative sign with a greater value. 10 is greater than, since 10 is greater than 3, therefore minus 10 is less than minus 3. So in this case, you have this minus 10 or 8 is actually less than minus 3 or 8. It means that minus 10 over 8 is what actually is it is an equivalent fraction of minus 5 over 4, and minus 3 over 8 is actually an equivalent fraction of minus 3 over 8 only. So again we can say here that minus 5 over 4 is less than minus 3 over 8. Now if you have to represent it on a number line, let's do that. So this is our number line. Okay. Now in this case, actually what? We have to deal with two negative integers. Therefore, let's start our number 0 from here so that we can have a better understanding, magnified of each unit. So let's say our minus 1 comes here. Okay, here to the right will be the positive integers, and minus 2 comes here, and minus 3 comes here. Okay, now this 8 means what? Each unit has to be divided into 8 equal parts. So if you have to divide into 8 equal parts, so take 7 marks at equal distance. 1, 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6. Sorry, we should have 7. We have to make some adjustment. 1, 2, 3, 4, 5, 6 and 7. Again this 1, 2, 3, 4, 5, 6 and 7. Now let's plot them. This is 0. This is what? This is actually minus 1 over 8. Same thing what we have done here. You have to just reverse it on the negative to the left side. Only you have to put this negative sign here. This becomes minus 2 over 8. This becomes minus 3 over 8. This becomes minus 4 over 8. This becomes minus 5 over 8. Minus 6 over 8. Minus 7 over 8. And this minus 1 comes as minus 8 over 8. This is minus 9 over 8. And this is minus 10 over 8. And you just go on. So here when you reach here, this becomes minus 16 over 8. Okay. Now, your this minus 3 over 8 is here, and minus 10 over 8 is here. Again, the greater value is towards the right of this, to the smaller value. Towards the right to the smaller value. Minus 10 over 8 is smaller, so it comes here. Okay. What if your fraction number was not minus 5 over 4, but it was 5 over minus 4, and it was minus 3 over 8. Can you see the difference? This is same, but this minus 5 over 4 is now 5 over minus 4, where negative sign, this minus sign, has changed its position and is now attached with this, the denominator. Now you have to remember one thing. This 5 over minus 4 is actually nothing else but minus 5 over 4 only. Because if you remember, we have discussed this point, that if P over Q, that's a general form of a rational number, if this is minus P over Q, this can be written as P over minus Q and can be represented as this minus sign in the middle, then P over Q. We have discussed these things. Okay, that's why I'm saying please watch our earlier videos. We can represent it like this. So if 5 over minus 4 is here, always think it of as minus 5 over 4. Right? So this 5 over minus 4 is actually minus 5 over 4. And there's a way to do this. Always you have to, whenever you are writing this in your examination, you have to show how did you convert this like this here. So what you can do is, like, this is 5 over minus 4. The concept of equivalent rationals. The concept of equivalent rationals. Just like equivalent fractions, equivalent rationals. This is no more fraction because now we have negative sign. So this is not a fraction, this is not a rational number. So equivalent rationals. What you do is you have to convert it like this. So 5 over minus 4, always convert this into an equivalent rationals such that that is in its standard form. Standard form. Now if you're thinking what's standard form, please again watch the earlier videos. Okay. So this is 5 over minus 4. So we multiply this with minus 1 and with minus 1. So whatever rational number now you get is actually an equivalent rationals because we have multiplied with the same number. So this becomes minus 5 and this becomes actually 4, right? So you can see here minus P over Q is actually P over minus Q. We have just proved it here. Okay. Now, as we said that 5 over minus 4 is nothing else but minus 5 over 4 and minus 3 over 8 only. So it means it's the same thing what we have discussed here. It's the same thing what we have discussed here. No difference at all. Okay. Okay. Next point. The main thing is that your rational number should always be in standard form, and in a standard form you cannot have this minus sign with the denominator. Minus sign can always be with the numerator, and your denominator should always be positive. Okay, that's important thing. What if your fraction number is 5 over minus 4 and 3 over minus 8? What if this is the condition? Again, you have to convert this in its standard form using the concept of equivalent rationals. So this becomes minus 5 over 4 and this becomes minus 3 over 8. Now again, same thing, right? Since the negative sign was with the denominators, therefore we changed it in its standard form using the concept of equivalent rationals. So now same thing again, you have to compare this one only. No difference at all. Okay. What if your rational number is written in this form? 5 over 4. And if you're wondering that why I'm always taking the same number, just to make your understanding, easier. Otherwise, every time we have to take LCM, then convert them into like fractions, standard form, it will take a lot of time. So the process will always be same whenever you're comparing any two rational numbers, 5 over 4 and 3 over 8, but your negative sign is like here, like this one. Okay, so whenever you are dealing with this condition, always think of this one. That is, your negative sign goes with the numerator. So this becomes minus 5 over 4 and this becomes minus 3 over 8, right? Now Can you see the same thing? Minus 5 over 4 and minus 3 over 8. So proceed with the same steps that we have followed till now. Next, what if this number is that we have to compare is 5 over 4 and minus 3 over 8. Again, this is a comparison of a positive number, a positive rational number, and a negative rational number. Now we know that whenever you have to compare positive, like we have discussed here, right? This one. Whenever you are comparing a positive with a negative rational number, then of course, however smaller the positive value is, it's always greater than the negative number. So it's 5 over 4, that is a positive, is always greater than the negative. It's always greater than the negative. So this is always greater. Okay. What if your number is, let me remove some space. I need some space. Next. What if your number is minus 5 or minus 4 and minus 3 or minus 8? Now again, these two rational numbers are not in their standard form. Okay. What does standard form tells? Standard form tells us that you cannot have negative integer as the denominator. So you have to get rid of this negative sign. Okay. So you have to get rid of this negative sign. So what you have to do is minus 5 times minus 1 and minus 4 times minus 1. This gives you 5 over 4, and this gives you, if you do same thing, minus 3 times minus 1 and minus 8 times minus 1. The main thing is that we don't want the denominator as negative numbers, okay? Because standard form has one another condition, that you should have only one common factor, that is 1. But we are not considering this step, that is we should always have only one common factor, that is 1. We want that our denominators should be positive. So this becomes 3 or 8. Okay, 3 or 8. Now you have two numbers, this 5 over 4 and 3 over 8. That means we have discussed this point also, that if your number is of the form p or minus q, then this number minus p or minus q is actually nothing else but p over q. And how? We just proved it here. Okay, so now you have to compare 5 over 4 and 3 over 8. Now you have to compare 5 over 4 and 3 over 8. It's same what we have done here. Okay, so the thing is, the most important thing is always remove this negative sign from the denominator, and the way to do is that simply multiply with minus 1. You have to show this step in your examinations. Okay, that's really very important. So this was, I think it's a very large discussion, but a detailed discussion of how to compare rational numbers.